So yo guys, what's up? Welcome to my channel. So today we are going to discuss a problem, that is the two-sum problem. In this what we have, there will be given an array of integers, and in that array we have to find two elements, for example that are a and b. These are two integers whose sum is equal to a given target. So an array would be given and a target would be given. You have to return these two elements which would sum and give me the target. Okay, now how to proceed? First of all, let's see an example of this. Okay, so let's take an example, that is 2 6 5 8 11. This is what we have taken. Now my target is 14. Okay, now what I have to do, I have to find two elements that sum up and give me the result of 40. Now there are actually two variants of this problem. First variant says you just have to return true and false, whether these pair of numbers exist or not. In the second variant, you have to return that elements particularly, right? So most commonly the asked variant is say the second one, but we will discuss both of these variants in this question. Okay, let's proceed. So first, what can I do? I can have a loop. So first is my brute force approach. In this, what we'll do, I will run a loop which will go to every element. First I am at 2. So if I'm at 2, I will search for the next elements, whether 2 plus 6 is equal to my target. No. Okay. Then 2 plus 5 is equal to my target. Is it? No. Then 2 plus 8 is equal to my target. No. Similarly 2 plus 11. Okay, so first for 2 I have to check to every other number. If I will take 6, then I will check with 2, not with itself. You do not have to check 2 with itself. Don't have to do it. Okay, then we have to check 6 with 2, 6 with 5, 6 with 8, 6 with 11. Similarly 5 with 2, 5 with 6, 5 with 8, 5 with 11. Is it giving me? So we have to check side by side. We have to check it also, that is it sum up to target or not. So is it 10? No. It is 30? No. Now is it 8? No. 11? No. 14? Yes. It is giving me the target. Okay, so if we have found the target, you just break from there. You don't have to do any other further questions, because you just have, this is the two sum problem. You have to return two integers, that is a and b, with sum up to my target. Okay, that's what we have to do here. So let's just write the code of it. 14. What I'm doing, I'm taking each element, I'm taking 2 and I'm checking for every other element, that is 6, 5, 8, 11. Then I'm taking 6, I'm checking for every other element, that is 2, 5, 8, 11. Then I'm taking 5 and I'm checking for every other element, that is 2, 6, 8, 11. Then I'm taking 8 and I'm checking for every other element, right? But here, as soon as this result comes 6 plus 8, then you will just break out from there. Okay, let's just write its code. What you have to do, you have to run a loop which will select these elements, right? So I have to select from 2 till 11. So I is equal to 0 to n minus 1, where n is equal to my array length or size if you were writing in CPP. I'm just here writing the pseudocode. Then if you have considered 2, then you have to check for the remaining elements. So I will say j is equal to 0 to n minus 1. But if I is equal to j, then you don't have to do anything. Else, if it is not equal to it, then you have to check if a of I plus a of j is equal to target, then what you will do, there are two variants of it. First is true or false. Next is you have to return that integers. So I can do both. What can I say? I can say here return true. And for the second variant, what I will do, I will take in here a list list, or you can take an array भी ले सकते हो of size 2, and you will say array of 0 is equal to array of I, not the array, it's actually answer. Answer of 0 is equal to array of I, it's actually a of I. Okay, we have taken a of I, and answer of 1 is equal to a of j, and you just have to return the answer here, right? And if nothing is found, then you just have to return false if you are searching for the variant 1, and you just have to return new int. If you are in Java, new int, you have to return new int. Okay, so sorry for this. You have to return -1 comma -1. This says that you have not found it, but there is, you can optimize this as well. Let's see how. For 2 I'm checking with 6, 5, 8, 11, and for 6 I'm checking with 2, 5, 8, 11. You can see from here, if here we are doing 6 plus 2 is not equal to my target, so is there need to check here? No, there's no need to check here, right? So what you can do, you can make a change in this. You can make a change in this loop, in the inner loop, where you are checking the element, this ith element you are checking. Okay, so for 2 I will check from its next elements. For 6 I'll check from its next elements, because if you check for 5 will check with 2, 6, 8, 11. But here it is already check, and here it is already check 6 and 5. So you just need to check for these two numbers. So the numbers which are arriving after this ith number, after this, you need to check only that element. So you will be like this, I plus 1, 2n minus 1, and this will eliminate, and this will also eliminate, obviously else will eliminate, and you just have to write from here. As the same code will remain the same, the entire code will remain the same, and this is your more optimized in the brute force. Okay, now let's discuss the next approach, that is the hashing approach. What I will do here in the brute force approach, now we are doing now better approach. Obviously in the brute force, what we are using 4 and 4, and its time complexity would be O of n square nearby, because here j is not going from 0 to n minus 1. We have made it more optimal by replacing it with I plus 1, so it is near to O of n square, and here, this is the time complexity, and for space complexity it is O of 1, because we are not using any extra space, and we are using answer of 2, which is just as equal to constant. Okay, now in better approach, what we will say, we will do hashing. We will take a hash map. This is in Java, and if there is a alternative in CPP that I don't know, you might do it. Sorry for inconvenience. Okay, so in hash map, what you will store the element. So first see, you will loop throughout it. You will just iterate over the array, and you just check if see. Before this, let's just see one thing. This is we have to return this a and b. If I fix a, then what would be b? B is equal to target minus a. This is the approach. Based on this formula, we are using this approach, hashing. So what we are doing, we are iterating over this entire array, and it is representing different values of a. We are here fixing, first time we are fixing 2, and checking for what? This is my 14 minus 2, and I'm checking for 12 in the hash map. So what you are doing, you are fixing a and checking for b in hash map. This is what you are doing. So where are hash maps used? You will wonder about that. How I know that here I am going to use hashing approach? So basically hash map is used whenever I want to track any if I'm going throughout the array, then I have to do some tracking side by side. For every element I have to track something. Here also we are tracking, but it is going to n square. I have to optimize it, right? Obviously the space complexity will become more bigger. Here it's O of 1, here it will be O of n due to hash map, but it will be more optimal in terms of time complexity. So what we will take, so what we are doing, let's just remember this and this, only these are the keys for this concept. We are saying target is equal to a plus b. This we are fixing a from the loop. If I'm at this element, I'm fixing 2, and I'm searching for 14 minus 2, that is target minus a, in the hash map. Does it exist? No, it don't exist. What I will do then, I will put this a into hash map, and I will mark its index. So what we'll take, this is the element and this is the index at which it occurs, right? Okay, next, so what we are doing here, do we find this 12 in the hash map? At this point the array was empty, sorry, hash map was empty. Okay, we do not find, you do not find, so just add this a into the hash map. Okay, now go for the next element. We go for this 6. What we say now, here we will check, here we will search for this element 8. Is 8 in the hash map? No, there is only 2. So you just add this a, this 6, into the hash map. Okay, now you go to this 5. Okay, now this will be like this. 14 minus 5 would be what? 9. Is 9 there? No. So what will I do? I will add this a. Remember, you have to add the a, not the b. You will add this a into the hash map. Okay, now for this, what we will do? Now my target is this. Target is obviously this. The target is the 14. Now my a is changed and it is 8 now. 14 minus 8 is 6. The 6 exists in the array. Now what happens? It will check, yeah, 6 exists in the array. So this is its intuition. This is the main reason for intuition, and I'm fixing this. If I don't find it, I will just add. Why I'm adding in the hash map? Why there's a need? What if this 8th element pair with any other element in the future? For example, here 6 do not pair with any of the elements on the left hand side of it, but it will pair with the element on the right hand side of it. That means the future element, the element which is present to the RHS of it pairs with itself. But with this, we are searching for the elements who are pairing with the left hand side of it. For 2, see, for 2 we do not have anything in the hash map, right? Because it has nothing in the left hand side. So how can I pair it? I can't pair it. So what I will do, I will just put it into it. And for 6 we are checking for with 2. No, it's not there. For 5 we are checking with 2 comma 6. No, 14 minus 5, 9 is not there. For 8 we are checking with this. So this is how its intuition will go on. That is the main thing for intuition. We are fixing the a with the loop, and with hash map we are finding the pth element. And as soon as we find this element, we'll just return true, or you can return the index. Now this is the optimal approach for the variant 2. We do have 2 variants. For the second variant, it is the optimal approach. Let's discuss the most optimal approach, but it is optimal for this, not for this. Optimal only if we have to return the true and false. Now just let's discuss about the time complexity of this hashing approach. Time complexity would be, what we are doing, we are having a loop for this. That means obviously it would be O of n. But side by side, what we are doing, we are adding every bth element into the hash map, and add operation of hash map takes log n. So it would be n log n. And what would the space complexity? Here it is, actually here it is 3. That is n minus 5 minus 2 is 3. Here it is n minus 2. So it is nearby to n. How it is nearby to n? How can I say it is nearby to n? So in the worst case, if I found the element at this, that means these elements have been put in the array. And more worst case is if I do not find any pair which sum up to target, so I will add these 5 elements in the hash map. So its worst case would be, for time complexity, would be O of n. Okay, so these are the root and better approaches. Now we are going to discuss the optimal approach. but make sure it is optimal only for the variant 1, in which we have to return the true and false, whether the pair exists or not. But for the second variant, this is the optimal approach of hashing. Okay, let's study about the optimal approach for the variant 1. Okay, let's discuss. Here what we are doing, we are going to use a two pointer approach, but before it I will just sort the array. Without sorting it won't be possible, the approach that I'm going to use. So first I will sort the array. I'll tell you why I'm sorting the array. I will initialize two pointer, one from left and one from right, and I will check if my a of I plus a of r is equal to target. Is it equal? No, it is 13, which is actually less than my target. So if it is less than, if I have this case where this sum is less than the target, then I have to move my left pointer, because I have to increase the sum so that it can make 14. But what if, okay, let's say we are increasing the L plus plus, so we are getting this. What is 11 plus 5? It is 16. Now 16 is greater than my target. What I have to do? Then I have to decrement the right pointer. Why I am doing this? Because I have sorted the array. It means the element here is less and here it's greater. Obviously, that we all know. And if I'm getting this sum L plus R, if I'm getting it less, it's not equal. If I'm getting it less, then I have to increase my sum. How can I increase my sum? If I go here, because here is a more greater value than this, so I will increment L plus plus, right? But what if my sum is greater than the target? Then I have to decrease the sum. How can I decrease the sum? I have to move r minus minus, because here the value is less than this value. Okay, so this is the main intuition of this approach. But here we are distorting the array. See, we have changed the array, so we can't return the indexes. Actually, you have to return the indexes. You can't return the indexes here, it will be wrong. So that's why for this second approach it is not optimal, right? We were here, we sum up, we get 13, which is less than my target, but I want to increase the sum, so I will do L plus plus. Okay, now it is what? It is 16, which is greater than the target. Now I have to decrement the sum, so I will do r minus minus. Now we get 8 plus 5 is 13. 13 is less than 14. So what I will do? I am getting a number less, so I have to increase the sum. So I will increment the L. Here what I will get? 8 plus 6, it is 14. Now 14, now this condition gets true. For 8 plus 6 is equal to my target, that is the 14. Now I have to return this. I will just return my L comma R. These are the pointers. But what if my target is equal to 20? Let's see for this also. What if I'll say this is equal to 13? Now what I will do? My target is 20. Now it is greater. If it is greater, I have to increase my sum. I will do L plus plus. Now here what I am getting is 5 plus 11 is what? 16. Now 20 is even more bigger. So I have to increment L. Here it is what? 17. Now 17 is also less than my target. I have to again increment the L. Now this is what giving me 19. 19 is also, so I will do L plus plus. This is here. But as soon as this, I can't take it. So if my L is greater than or equal to R, I can't take it. This means if this is the condition, I can take it. So I will run a while loop. If my L is less than R, I will run this if my A of L plus A of R is equal to target. Then you just have to do what? You have to return L comma R, right? But if A of L plus A of R is less than the target. If it is less, then you have to do L plus plus, else only one condition is left, that is this sum is greater than the target. If it is there, then you have to do the sum is greater. You have to decrement the sum. That means decrementing the R. And if you do not find, you just have to return -1, -1. That's it. As simple as this. This is all about the two-sum problem. In the brute force, what we are doing? We are having a O of n square. For the first loop, for the outer loop, we are taking every element one by one. And in the inner loop, I am checking for again for every other element, which is just after that element. Because for 2, I am checking for 6, I am checking for 5, I am checking for 8, then 11. Okay, for 6, I am checking for 5, 8, 11. For 5, I am checking for 8, 11. For 8, I am checking for 11. For 11, I am not checking anyone. So I will say I is equal to 0 to n minus 1 and j is equal to I plus 1 to n minus 1. And the same condition is applied if array of I plus array of j is equal to my target. Then you just have to return true. Okay, or you can return new int and the index I comma j. And if you don't find at the end of the loop, you will return false, or you can write -1 comma -1. Right? This is with the brute force. Here the time complexity is O of n square and space complexity is O of 1, because we are not using any extra space. We are using just the answer of 2, which is just equal to constant. Right? It is 2 every time. We have to find the 2 elements. In better approach, now what is its intuition? In better approach, we say 2 things. First we say target is equal to A plus B. I will fix it by the loop from 0 to n minus 1, and this I will search in hash map. I will search for this in the hash map, and if it's not found, then I have to add A into the hash map, right? And for this, the time complexity was on for this A, and as we are adding that A element in the hash map, so we have log of n. This is the time complexity, and for the space complexity, it is O of n, as we are using the hash map, which at the worst case can store all the elements. Now this is my optimal, which is optimal only for the first variant. This is my optimal approach. In this first, what we are doing, we are sorting. For sorting, the time complexity is O of n log n. Then we are iterating on every element, that means O of n. Right? We are iterating on every element, and what we are doing, this is what we are doing. We are checking for the logic is that you will just you have to just sum up them, and if L plus R, A of L plus A of R, if it is equal to target, then no worries, you have to just return L comma R. But if their sum is less than the target, sum is less than, you have to increase that sum so that it must be equal to the target. So what you will do, you will increase L plus plus, because it is sorted, these values will be sorted in ascending order, right? But what if the sum is greater than the target? I have to decrement the sum so that it can be equal to the target. So that would be by decrementing the right pointer. So this is the 2-pointer approach for optimal. And for space complexity, here space complexity is O of 1. We are not storing any space. There is a space of answer which is 2. In this case we are not doing this. So we are returning only the true and false. That's it. That's it for today. You can't return. I'm so sorry to say this. You cannot return -1 comma -1, because we are distorting the array. This L comma R, these are wrong. Here it is 0 1 2 3 4. Here it is 0 1 2 3 4. 6 is at 6 and 8 you will return, but actually the answer will be 1 comma 3. Here it will give you 2 comma 3. So that's wrong. So you just have to return true or false. You will return here, this is true. Here you will return false. Got it? So this is all about the two-sum problem. This is a very important problem which is asked in many interviews. So that's it. If you have any doubts,